Look around your kitchen. When you shut a cabinet door, you assume it stays closed because of a simple hinge, gravity, and friction. You expect the architecture of your home to be completely passive, dead weight hanging perfectly still. Behind those doors, there is an active, engineered resistance. Take a modern push-to-open catch. Instead of relying on you to pull a handle, this tiny mechanism is packed with heavily calibrated magnetic tension designed to violently repel a heavy wooden door outward. You apply a fraction of an ounce of pressure, and the structure instantly springs alive. The wood launches towards you, driven by a hidden payload. Every surface in the modern home exists in a state of kinetic potential, spring-loaded and calibrated to react to a human touch. We tend to assume that the tiny latches hiding in our furniture are stamped out of low-grade iron or cheap steel. In reality, modern cabinet latches rely on neodymium, a highly refined rare earth alloy. Extracting these materials requires ripping open massive, terraced open-pit mines and processing tons of raw ore to yield a handful of usable magnetic material. This diagram shows the resulting force-to-size ratio. On one side, you have a rare earth disk magnet the size of a dime. On the other, a solid block of dead weight. A sliver of processed rock supports 14 kilograms of gravitational pull. Installing one of these inside a bookshelf anchors your everyday furniture with advanced deep earth material science. This raw holding power creates an immediate engineering problem, attaching a viciously strong metal lock to a sheet of fragile glass without drilling structural holes that would shatter the pane. The solution in high-end glass hardware is a specialized UV glue system. Engineers use ultraviolet light to cure an adhesive that fuses the metal hinge to the glass at a molecular level, completely bypassing the need for drills or screws. But attachment is only the first hurdle. Raw magnetic attraction is aggressive. When two rare earth metals catch each other's field, they accelerate rapidly, resulting in a loud, sharp kinetic impact. To prevent your cabinets from slamming like a vault door, manufacturers embed microscopic sound-absorbing rubber pads and complex fluid dampers inside the catch. They capture that kinetic energy and bleed it off, bringing the metal to a soft, dead stop exactly at the point of collision. The quiet, aesthetic perfection of your kitchen requires a carefully orchestrated physical system designed specifically to muzzle violent kinetic energy. Most of us picture magnets as simple shapes, flat discs, long bars, or basic horseshoes painted red and blue. To hide these mechanisms entirely, designers use concealed tap-in hardware. These cylindrical catches are driven directly into the flesh of the wood, disappearing completely from view. This 3D vector model shows a Hellbach array, a specialized geometry of permanent magnets. Instead of projecting a uniform field, the array contorts the magnetic force, heavily focusing it on one active side while canceling it out on the back. By steering the field in exactly one direction, the magnet achieves maximum grip on the strike plate without bleeding pulling force into the surrounding wood or interfering with the electronics in your home. Magnetism operates as a highly malleable force that engineers actively sculpt to fit inside the walls of your home. Left untreated, standard metal hardware has a predictable lifespan. Constant exposure to moisture and friction inevitably leads to rust, degradation, and mechanical failure. To survive decades of heavy use, modern magnetic latches are shielded in advanced chemical coatings, like titanium nitride. This is the exact same ceramic material borrowed directly from the aerospace industry to harden NASA jet engine turbines against extreme environmental stress. Protected by these coatings, small, heavy-duty stainless steel catches can secure massive industrial doors, generating the exact same physical resistance as a heavy, interlocking mechanical drawer slide. Because these mechanisms lack internal moving parts to fail and use surfaces that resist chemical breakdown, they are often the only components left functional after the surrounding wood or structure has decayed. We assume this highly tuned technology is strictly reserved for interior design and fine cabinetry, but the exact same magnetic principles are scaled up for high-stakes tactical environments. Police and military units rely on heavy-duty gun magnets for secure weapon retention inside moving armored vehicles. The applications branch out into completely different extremes.
Veterinarians use specialized cow magnets to safely trap ingested stray wire inside livestock stomachs. Construction crews deploy massive magnetic shuttering systems to hold heavy molds in place while pouring tons of liquid skyscraper concrete. A single, highly efficient mechanical solution scales up and down to solve physical problems across the entire global economy. Sustaining this domestic illusion of order requires a massive, coordinated industrial matrix. A single magnetic latch represents the convergence of tens of thousands of branded parts, manufactured to unified international standards and distributed across 80 countries. This invisible network operates entirely in the background, working silently to keep the physical infrastructure of the modern world from literally falling open. Every time you interact with a simple door, you are commanding rare earth metals forged deep underground, triggering microscopic silencers, and engaging a massive, unseen web of engineering designed specifically to hold our world together.